Yeah, so we'd been through distributive law 1 and we got to probably around this question 4, expand and simplify, which may be proving challenging. Hands up if you're up to question 4. Hands up if you're just before question 4. Hands up if you're past question 4. Okay, so what I'll tend to do now then is go back over the distributive law easier questions and then we'll come to these more challenging questions. So a recap of the distributive law was the use of those arrows. Everything outside of the brackets had to be multiplied by that which was inside the brackets. Okay, so if we simply take 2x plus 1, 2 had to be multiplied. Remember that there was a multiply sign in there, and that's the key thing we have to remember. Damo, keep paying attention, please. 2 multiplied by x becomes 2x, and then you had to multiply it by positive 1. What was the rule with the positive 1, Ben? What was the understanding of that sign?
The number after the sign goes with it.
Yeah, good. The sign belongs to the number which comes after it. So it's 2 times positive 1 gives us positive 2. And that's as simple as we could have got that. When we take out another one, let's do this. A multiplied by negative a plus 5. A multiplied by negative a gives us a positive and a negative. Remember we go through, we do the signs first. Positive and a negative, Tish, gives us a negative.
Negative
A squared, good. Okay, and then we do a multiplied by 5, a positive and a positive gives us a positive. A multiplied by 5 gives us 5a, so negative a squared plus 5a. I know a couple of you are away. Those that weren't away, is this starting to ring a bell? Yeah? Hands up if you've finished all of question 1. Okay, let's go through a couple from question 2. I'll take this one. All right. Again, everything outside of the brackets affects that which is inside. So we are multiplying 2 by 3a. We do the signs first. Positive and a positive, so it must be a positive. Then we do numbers. 2 multiplied by 3 is 6a. Okay, and then we do the letters, or the coefficients. So 2 times 3a. What's the next one, Maddie? Yep, so I've done the arrow for this first one, 2 times 3a. What's this one now become? It's minus 5b. What are we doing with minus 5b? No, not quite. No, with the arrows, Jordan? We're timesing it by 2. So what we're doing is like reading a book from left to right. 2 times negative 5b. Alright. So what would 2 times negative 5b? Maddie, I'll start with you. 2 times negative 5b. Excellent, negative 10b. And then the next one, Brooke.
2 times 1.
Which gives us
1. No, 2.
positive 2.
Yeah.
That's right. Okay. Is there any like terms there? Because that'd be the fourth thing we do, would be to start to look for any like terms. Okay. There are no like terms. A's, don't go with B's, and don't go with straight numbers. So we just have to leave it like that. Are there any questions with that? Or am I going too fast for some people? Nods? Yes? No? Not giving me much. Give me something. Go too fast? I'll keep moving through some examples then, rather than switching. So we'll go through 3 and 4 now. A couple of examples from 3 and 4. Hands up if you're in 3. Okay, plenty of you. We'll take this first one. I'm suggesting to you just to leave the 2 by itself. Okay, so bring the 2 down. So if we had this question set out like this, my suggestion to you is the next line is to just bring this 2 down, but then just look at this like you had those previous questions that we've just been through, particularly in question 1. All right, so imagine that that's not there at all. All right, so you're left with plus 3, x plus 1. 3 times x gives us 3x, and 3 times 1 gives us 3. And this is where we have to collect like terms. Paris?
2 and 3.
Gives us
5.
Yes, 2 plus 3, that belongs to that, gives us 5, plus 3x. Yeah? Any questions with that? Maddie, is that alright? I mean, you're away, you've been away. Let's look at one where there's a negative in there. 4x take 1 plus 7. Okay. 4 times x gives us 4x. 4 times negative 1 gives us negative 4. Just bring that down. Okay, just like we did with the 2. It's outside of the realms of that, so let's just bring it down. Then we can collect like terms. Lockie?
The 4 minus 4 and 7.
Excellent. Minus 4 and 7. What does that give us?
Minus 11.
So I'm at minus 4. And I'm adding 7. 1, 2, 3, 4, 5, 6, 3. Plus 3. Okay. You guys, I can't implore you enough. If you're going to... Lockie's not the only one that would have said negative 11 there. If you don't know your negative numbers and the number line process, draw one in the back of your book. I have asked you to do it a long time ago. Please use a number line. Because you know what, folks? It's not algebra that's going to get you wrong. It's not algebra that's hard. You can do algebra. What is it? What is it that you struggle with? Negative and positive, which is number. Which is what you're doing in year 6, 7 and 8. Okay? So it's not good enough to sit there and go, oh, algebra's no good. Algebra, I can't do algebra. You can do algebra. You're showing it all the time. What you can't do is number if you don't use your number lines, okay? Just use a number line. It's what is it? 5 more seconds of effort for the right answer, which is probably worth it, okay? It's just the number line and the negative and positive numbers, all right? I'll pick one from down here now. Okay, I might pick that first one. 2x take 3 plus 3x plus 4. And maybe what I suggest is you just, again, separate them. Imagine this isn't here and just do that on its own, just looking at that on its own, which might help you. And then don't worry about what's there, just do this on its own. 2x, positive and a negative, we do the signs first. 2 times 3 is 6. And then we've done that one. 3x, so it's positive 3x. 3 times 4 is 12. We collect like terms, and our like terms are positive 3x and positive 2x, and negative 6 and positive 12. They're our like terms. So, Damo, what do we do with the x's?
Add them together.
Yep, what do I end up with there?
5x.
Excellent, 5x. And Liam? Okay. Look at your number line. Look at your number line. It's -6, yeah, what do I do with -6?
Put it on the end.
You could put it on the end.
Or
You could put it on the end. Yep, what's the answer going to be if I was to do that?
6.
6. So what do I put in here?
6.
Plus 6. Yeah, okay. So all we're doing is simplifying them, expanding them first, alright, by using our distributive law 1, and then we're simplifying them down. Is there any from question 4 you'd like me to go through? You're probably pretty punchy to get into it. Any with question 4 you'd like me to go through? No? Reckon you're alright with that? Who's in 4? Sorry, show of hands. Who's in question 4? Yep, what question are you up to, Will?
Starting B.
B. Yep.